Okay, in our last lecture, we were talking about categorical data, and we've moved into descriptive statistics. So remember, descriptive statistics is we want the people, our audience, or even ourselves to wrap our heads around the data that we've collected. So my illustration from before was we're walking in kinder care. There are toys all over the floor. And the names of these toys are categorical. It's a Barbie doll, it's a Hot Wheel car. And so, in order to describe this, what we did is we cleaned all this up, put it in its bins, and we created a frequency distribution. So we just counted it up. That's all we could do. We cleaned it up, put everybody in their bins. I got 10 Barbie dolls, I got 5 Hot Wheels cars, whatever. Well, we want to do the same thing today, but we want to do it with quantitative data. So this is data that's a number. So categorical is a word, but quantitative is a number. So this is not the story about my toys. I wish it was, but here's the point. I walk into the room and now, instead of toys being all over the floor at KinderCare, I've got numbers. Suppose somebody was playing with some kind of card game and it's got, or lottery balls or bingo or something, and now there's just numbers scattered throughout the entire place. Well, if I wanted to describe all of those numbers to someone, I wouldn't just go around, pick up one ball. Oh, here's 17. Here's 43. Here's 20. Oh, look, for some reason there's another 20. That doesn't describe it. So what we're going to do is we're going to collect it just like we did before, and we're going to put it into bins. Now, the difference between this time and last time was, in the last time, if my pen will write, why is it not writing? Okay. Last time, we just collected the toys and put them in these bins. They're not interconnected. This is just the names of all the toys. But this time, these numbers do have some kind of connection. If you followed a number line, there would be a relationship here. Like you could go straight up the number line. So what I'm getting at is this. This time, I want our bins touching each other. I want them right up next to each other. With the toys, it didn't matter. But here it does because we're following a number line right up top, okay? So here are our bins. And what we would do now is we go around the room and we start collecting the numbers into these bins. Well, how are we going to do that? Well, the first thing we're going to do is we're going to decide on how wide we want all of these to be. So 5 or 10 is usually standard. Computers might get fancy on you, but so we want our baskets to be a width, let's say, of 5. It's called the class width, okay? So our width here is 5. So what I'm going to do is I'm going to just number all of my baskets. So here's the width. You see I've got my widths of 5 here. Now, I'm going to go around the room and I'm going to pick up the numbers that fit into each of these bins, each of these baskets, and I'm just going to throw them in. The numbers between 10 and 15 belong here, between 15 and 20 here, 20 and 25. And I just collect them. And then I'm just going to tell you how many of them that I have counted up. So if you see, though, we got a little bit of a problem. So here's a frequency table. You can ignore this for the moment, but this is a frequency table. I went around and I counted up how many numbers fell in each of the baskets. But do you see what's strange here? This has a class width of 2. Each of the bins keeps going up by 2. This is called the lower class width. Here they all are, 60, 62, 64. But what about the number 15? If I had 15 laying on the floor of this this KinderCare room, which basket am I going to put it in? Because this basket ends right there at 15. Or what about 20? Which basket do I put it in? Well, the customary way to fix this is we're going to put it in the larger basket. And what we think of is that the first basket ends just before the next basket. So what I'm saying here is in this one, my class width is 2. So my baskets are going to keep going up by 2. 2, 4, 6, 8, all the way up. Now, because we don't want overlap, the lower basket is going to end just before that. Okay? So here are some terms. I got class width. I probably have a slide for this, but I got a class width of 2. Now, these are called the lower class limits. and I might ask you for all of them. So 60, 62, 64, that's the lower class limit. In other words, that's the lower number for each of my bins. Those are all lower class limits. These then are called the upper class limits. So we go around the room, we pick up all the numbers, and we drop them in to their appropriate bin. We've got them all organized. You can do relative frequency if you want, where you turn them into percents again. But we have cleaned this up. Now, once you've cleaned it up, a picture is worth 1,000 words. We turn it into a picture. This is a different illustration, but it had a nice histogram, so I pulled this out of a book. So here we go. Between 10 and 13, I picked up this many. Between 13 and 16, this many. So remember, the number 13 would be in this bin, 16 in this bin, 19 in this bin. And there we go. We've created a picture. So instead of clutter all over the floor, just data piled upon data, we've created this histogram, which in a moment gives us a glimpse of what's happening with this data. And we're going to mention some more about this in just a second, but it's even a bigger deal than you might imagine. This picture here turns out to be extremely significant for all of the stuff that continues on with stats. But let's go through now and look at some details here, okay? So we've got quantitative data. And just like before, there's some ways we can show quantitative. So there are numbers all over the floor instead of words. I showed you one here. We've made a histogram. Now, you could have literally made a dot plot. I would never test you on this. You might see this in math lab. Dot plot is just literally marking. So they had numbers between 0 and 9 on the floor. And this literally shows every single one of them. So this showed how many of each data value you have. I don't care much for that one, but it works. You could. But the summary of a histogram is going to turn out to be a much bigger deal. This kind of collective picture is really important. Now, we've got one last way that we can display quantitative data. It's called a stem and leaf plot. You've probably done this sometime in your past, but let me just show you with an illustration. So there's numbers laying all over the floor. Here's our data, all right? What you do is you're going to make a stem, and it changes on the context, but the leaf is going to be the last digit. So you chop the last digit off of all of these. Then you make your stem. So this stem represents the 30s. This is the 40s, the 50s, the 60s, the 70s. So this represents that first data point. Your leaf shows all the different numbers you have in the 30s. So here's 3. This represents 33. Now you go down to the 40s. I have 2, 9, and 9. What does that mean? 42, 49, and another 49. You just keep proceeding in this manner. So here's your numbers in the 50s. Here's your numbers in the 60s, 70s, right on down. Now, it is essential that you make me a key, because sometimes you could be working with numbers like 3.3 or 4.2, and you would chop off the last digit, and this stem would represent the number 3, 4, 5. It wouldn't be the tens place. It would be the literally 3, 4, 5. So the key helps me understand what it is that this data represents, because it could be decimals. Do you see what I mean? So you got to make me the key for full credit, and here's your stem and leaf. You'll practice this in just a minute. Okay, now there's some different variations in here. You might see this in math lab. You'll get it. I guess I'll mention this one. A split stem is just this. Instead of making this all of the 30s, because sometimes maybe there's a clutter of numbers, they go from they're breaking it up at, let's see. Yeah, they're breaking it up. This is 50 through 54, and then this is 55 through 59. Just again, because they have a lot of clutter. That's the only thing they're doing there, splitting those stems up, cutting them in half so that you can see the data a little more clearly. Okay, there's something called back-to-back. None of that's super important. Here's what we got so far. You go in the room, you want to clean up the clutter. So we've got quantitative data this time. You could do it with a dot plot, not really very interested, wouldn't test you. But you could do a histogram, and you can do a stem and leaf, okay? Now, a histogram is good for huge piles of numbers. But a stem and leaf is good if you want to see. It does show you every single data point, so it's got some value. But it shows you every data point, but that would be really hard to do if you had lots of them. Anyway, let me wrap it up with this. That picture that we've created is really important. And this is about descriptive statistics. So if I say, hey, describe for me this histogram, well, what are you going to do? This teaches you some super important things, which we're going to focus on over the next week or two, and then again later. And it's these three. If I say describe a histogram, describe that picture, it's got three things that you're interested in: the shape, the center, and the spread. Now, I'm not going to focus much on a uniform. Do I have one? No, I don't even have one. A uniform would be a histogram that turned out to be basically straight across. That's uniform. Okay? So you're going to describe a histogram, you got to hit all these. Shape. Your choice is uniform would be this one. But what you're going to tell me next is symmetrical or skewed, either right or left. This is symmetrical. This one is literally perfectly symmetrical. It doesn't have to be perfect, but you see this makes a nice bell-shaped curve. It's symmetrical, like you draw down the middle. It's essentially the same on both sides. You go over here, this isn't perfect, but basically symmetrical. So you've got your shape, we've got uniform, symmetrical, or skewed. If you look at this one, it has a tail. It runs off. Now, you could be skewed to the right or skewed to the left. So what's the difference? Well, the skew is as you're looking at it. So as I'm looking at this histogram, the tail runs to the right as I'm looking at it, and that's the proper way. So that is skewed to the right. It has a tail to the right. If you look at this one, it's skewed to the left. It's got a tail to the left. So you look at the histogram, and this tells us some stuff, important stuff. It tells us whether it's the shape, symmetrical or skewed. And for the center, at this point, we're just going to take a guess on where this thing would balance. Do you ever have those old school teeter-totters where you could get down and you could like move the center, the balancing point, so that the thing, you got like the big, huge kid in the neighborhood sitting on one side, and then the other side, they've got this little tiny kid. The way to offset that was to move the center, the fulcrum of the teeter-totter, so that it would balance. Well, fine for now. We're going to get more specific next week, but for now, just find the place where you think the weight would balance out. Do you see here that maybe if I put the teeter-totter pivot right about at 15, that would offset the weight, the bigger side over here. So find the balancing point, and that's the center. And the spread is literally just the range. You're just going to tell me where you go from. You have data ranging from 0 all the way up to 24.99. That's it. Now, we'll get more specific with this. This is the whole focus of next week. But these histograms are important. They tell us the shape, the center, and the spread, which are going to be a really big deal. Okay, hopefully that helps.